So let's talk just a little bit about what is software engineering. We've talked about it in the broad scope of how does it equate and how do we make maintainable code and how do we have high quality projects. But let's talk about why and how it's incorporated into today's business environment. As we're relying more and more on software in our everyday lives, the importance of it has grown, and the software community has come up with various ways to attempt to develop technologies to make it faster and easier to develop software applications. There's a lot of different things that have been involved. Some of them are very high tech, things like AI coding assistants, no-code and low-code coding solutions, as well as design patterns and software libraries that are easily imported into a project so that you can write software without having to write too much software. As hardware and software systems have become more and more complex, the demands on what's required of them have also increased in complexity. Because of this complexity, as well as the multitude of types of domains for both how and where software is being developed, the odds of finding a single unifying method will be very slim. That doesn't mean that there's not ideas that we can use that we can make for each of our projects to get better. Now you might ask, well, what do you mean when I talk about different types of domains of software that are going to require special solutions? Well, let's look at a couple different types of domains of software development. This includes things like system software, your operating system, device drivers, low-level systems that are integrated into small, simple computer systems that are controlling everything from your car to your microwave. Application software. This is what we typically think of when we talk about software that goes on a desktop or laptop computer. Things that are domain-specific, like engineering, statistics, etc. Web-based and mobile application systems. Those require completely different environments and different systems than what we're used to. If you've been listening to the news that's been coming out about software development last couple of months, all you hear about is artificial intelligence. What does that mean and how does that work? How can we have bugs when the system's kind of designing itself? Well, believe it or not, it's quite easy. And artificial intelligence itself covers a wide variety of different topics because we have artificial intelligence that talks about things like machine learning to image design, musical, writing in natural languages, etc. In truth, artificial intelligence has been around since the 70s and is used in a wide range of topics itself. So if we talk about all these different domains, they're all very different. The complexity and differences in those different types of domains makes coming up with a single unified process very difficult. And software engineering often gets a bad rap amongst the other engineering fields because when we look at other engineering, whether it's civil engineering or electrical engineering, mechanical engineering, etc., it's all about how do we produce reproducible methods that ensure that it's going to work. Yet each one of those domains is completely different, and taking the principles and ideas that works in one doesn't mean it's going to work on another, and in fact may mean it won't work. So what is a software engineer going to do? Well, the IEEE says that software engineering is the application of systematic, disciplined, and a quantifiable approach to the development, operation, and maintenance of software. That is the application of engineering to software. So it's taking those same ideas. It's taking the same way that you feel confident that the bridge you drive over is going to support the weight of yourself and your car, and those other 100 cars are on the bridge with you, because they've looked at other bridges and they figured out what works and what doesn't work, and they use the same systems. As a software engineer, we have to apply those same principles so that it's approachable from a repeatable standpoint. we might have to subdivide software engineering and IT engineering in general into different categories in order to make it successful. This is an ongoing field of study. This is an ongoing practice where we're continually working to develop those methodologies to get better at producing products that are on time, on budget, and deliver the requirements that are needed. That's what software engineering is all about. So coming up, we're going to look at different ways that we can work on meeting those standards, different methodologies, different practices, etc. All so we can have repeatable software that's going to work for our end users.